Hello again. In this video, I'm going to go over some examples where we use the chain rule. So you may remember in the last video, I introduced two forms of the chain rule, and I tried to show you where they came from. But now we're actually going to apply both of those forms of the chain rule to some examples to find some derivatives. Now let me just remind you of the two forms of the chain rule by going over Theorem 313. So Theorem 313 says, suppose y is equal to f of u is differentiable at u equal to g of x. And u equal to g of x is differentiable at x. The composite function y equal to f evaluated at g of x is differentiable at x, and its derivative can be expressed in two equivalent ways. And so the first way is that dy dx is equal to dy du times du dx. And then the second way is that the derivative of f composed with g of x is equal to f prime evaluated at g of x times g prime of x. So one thing I want you to take note of is regardless of which form of the chain rule that you're going to use, you'll get the same answer either way, but you do need to satisfy two conditions here. Y needs to be a function of u. In other words, y needs to be written in terms of u. And u needs to be written in terms of x. So u needs to be a function of x. Okay, so let's do a couple of examples where we use the chain rule. Okay, so let's say we have y is equal to u to the 7th, and we know that u is equal to x squared plus 5x. And what we want to do is we want to find the derivative of y, but with respect to x. Now that's important. That's an important distinction, because if someone asked me to find the derivative of y with respect to u, then I wouldn't have to use the chain rule. The derivative of y with respect to u is simply 7u to the 6th by the power rule. And that's because y is written in terms of u. Okay, but that's not what we're wanting to find here. We don't want the derivative of y with respect to u. We want the derivative of y with respect to x. And notice that y is not written in terms of x. So that causes us a bit of a problem. And that's the reason we're going to have to use the chain rule. Now notice we do know that we know u in terms of x. And so this does satisfy the two conditions that you need to use the chain rule. So remember, y needs to be written in terms of u, which it is, and then u needs to be written in terms of x. And so this qualifies as a case where we could actually use the chain rule. Okay, and so we're going to use the first form of the chain rule. The first form of the chain rule says that dy dx is the same as dy du times du dx. Okay, and so we just found dy du, right? Dy du is 7u to the 6th power, using the power rule. And then du dx would be the derivative of this with respect to x, which is 2x plus 5. Okay, by the way, this is called the outer derivative, and this is called the inner derivative. Okay, so our outer derivative is 7u to the 6th, and our inner derivative is 2x plus 5. Now, just to finish this off, we don't like having a mixture of variables here, so let's replace the u with x squared plus 5x, since that's what u is equal to. And so that would give us 7 times u to the 6th power, but u is equal to this, so it's really this to the 6th power. Okay, and so that's our outer derivative. And then our inner derivative is just 2x plus 5. Okay, so that's dy dx, right? The derivative of y with respect to x, using the first form of the chain rule. Now I'm going to go ahead and do it using the second form of the chain rule. So if you want to use the second form of the chain rule, the second form of the chain rule says that the derivative of a composition of two functions, f composed with g, is equal to f prime evaluated at g of x times g prime of x. Now note, this is going to be your outer derivative now, and this one's going to be your inner derivative. So you're going to get the same answer. And we'll see that, okay? But first we need to write this as a composition of two functions. So let's take both of these and actually write it as a composition of two functions. So we know y is equal to u to the seventh power, and we know u is equal to x squared plus 5x. So if we substitute for u, that would be the same as x squared plus 5x, right? That's equal to u. So we're going to get x squared plus 5x to the seventh power, and that will be equal to y. And so this is really a composition of two functions. So you can think of this as being an outer function, which is x to the seventh power, and an inner function, which is the x squared plus 5x. So you have to see that this is really a composition of those two functions. And therefore, if you're going to find the derivative of this, dy dx, you're going to have to use the chain rule. So that's one way of remembering that you need to use the chain rule. Anytime you're taking the derivative of a composition of two functions, you need to use the chain rule. Okay, so let's find dy dx, okay, using the chain rule. So the second form of the chain rule says that it's f prime evaluated at g of x. All right, so let's find f prime. F prime of x would be 7x to the sixth power. But then we have to take that and evaluate that at g of x. Okay, where g of x is x squared plus 5x. So this is f prime evaluated at x squared plus 5x. And so what that's going to give you is, when you plug this into the derivative, what does the derivative do to anything you plug into it? It raises it to the sixth power and then multiplies it by 7, right? That's what the derivative does to any number that you plug into it. So if you're going to plug this into it, it's going to take this, raise it to the sixth power, and then multiply that by 7. Okay, so that is f prime evaluated at g of x. In other words, your outer derivative. Okay, and now we have to multiply that by the inner derivative, which is just g prime of x. In other words, the derivative of this function. Okay, so g prime of x, of course, is 2x plus 5. Okay, so this is your outer derivative times your inner derivative. And in a nutshell, that's what the chain rule says. Regardless of which form you're using, it's the outer derivative times the inner derivative. And notice you get the same thing. That's the same thing we got up here. So it doesn't matter which form of the chain rule you use, you'll get the same answer. Okay, so let's look at another example. Okay, so y is equal to this square root of x cubed plus 8x squared, and we want to find the derivative of y with respect to x. Now, if you were to give me this problem, the first thing I would notice is that this is really a composition of two different functions. And so that would immediately lead me to thinking that I need to use the chain rule to find the derivative. Again, anytime you take the derivative of a composition of functions, you need to use the chain rule. Okay, so let's write this out explicitly as a composition just to be clear about what f and g are. Now f is going to be the outer function, so if you view this as x cubed plus 8x squared raised to the 1/2 power, that's the same, raising it to the 1/2 power is the same as taking the square root of x cubed plus 8x squared. So what I would say is anytime you have radicals, you should always write them in terms of their exponents before you find the derivative. Okay, so let's write that as x cubed plus 8x squared raised to the 1/2 power. And then if you want to form a composition here, f of x is the outer function, which is x raised to the 1/2 power. And then g of x is this inner function, x cubed plus 8x squared. Okay, and so let's find dy dx using the second form of the chain rule. Okay, so we need to find f prime first. Well, using the power rule, it's just 1/2 x raised to the minus 1/2 power. Remember, you subtract 1 from this exponent, so 1/2 minus 1 gives you minus 1/2. And then you have to take this and evaluate that at g of x. And g of x is equal to this. Okay, and so when you evaluate f at this, what you're going to get is you're going to get, notice the derivative, what it does is whatever number you plug into it, it raises it to the negative 1/2 power and then multiplies that by 1/2. Okay, so this is the number you're plugging in to the, I'm sorry, this should be the derivative, right, f prime. You're plugging this into the derivative. So it's going to take that number and then raise it to the negative 1/2 power and then multiply that by 1/2. Okay, because that's what the derivative does to any number that you plug into it. Okay, so this is going to be our outer derivative. And then we're going to multiply that by the inner derivative, which is g prime. And you can see here g prime is 3x squared plus 16x. Okay, so again, remember in a nutshell, the chain rule is the outer derivative times the inner derivative. This is the outer derivative. Times the inner derivative. Which again is coming from here. The outer derivative times the inner derivative. Okay, so there's a quick way of doing this. Once you get really used to the chain rule, the really quick way of doing this is anytime you see that you have a composition of two functions like you do here, and you want to find the derivative of that function, you know you're going to have to multiply the outer derivative times the inner derivative. And so a quick way of doing that is the 1/2 power right here, you're going to have to take that down in front and then subtract 1 from it in order to find the outer derivative. And then when you're done, you just replace the inner function, back into this x. So what you can do is just leave it there. Let's leave this there, pull the 1/2 down in front, and then subtract 1. And you'll get this. And then all you do after that is take the derivative of this inner function, which is 3x squared plus 16x, and you multiply by that, the derivative of this inner function. So that's a quick way of doing it. So once you get good at this, you don't have to continue writing this out. Now I do suggest that you continue to write it out like this until you get really good at it. But once you get really good at the chain rule, you should be able to do this in one step right here. Okay, so let's look at a couple more. Okay, so here we have y is equal to sine of x cubed. And we want to find the derivative of y with respect to x. Now again, the first thing I would notice is that this is really a composition of two functions. It's the composition of sine of x and x cubed. Sine of x is the outer function, so I'm going to call that f of x. And then x cubed is the inner function, so I'm going to call that g of x. Okay, and so again, I'm going to use the second form of the chain rule, which says that the derivative of f composed with g is f prime evaluated at g times g prime of x. Okay, so let's start with f prime. All right, well, we need the derivative of sine of x. The derivative of sine of x is cosine of x. And then we have to evaluate the derivative at g of x. Okay, and of course, in this case, g of x is x cubed. And so when you evaluate the derivative at x cubed, you just get cosine of x cubed. Okay, so that's our outer derivative. And now we just have to multiply that by the inner derivative, g prime, okay? And the derivative of g prime, the derivative of g prime is 3x squared. Okay, and so now we just have to multiply the outer derivative by the inner derivative. So it's cosine of x cubed times 3x squared. Okay, so that's how you do that one. Now let me do one more. Okay, so this one is actually a little different than the previous one, even though it looks very similar. This is actually y is equal to sine cubed of x. So there's a difference between the last one and this one. This is sine of x cubed, and a lot of times we just write it like this. So those are the same thing. Now you don't want to get that confused with the problem we just did, which is sine of x cubed. Okay, so that's what we did in the last one. Okay, so let's find the derivative of this. Okay, so again, the first thing you should notice is that this is a composition of two functions. Okay, so the outer function is now x cubed, and the inner function is sine of x. And it's much clearer if you write it like this. You can see here that sine of x is actually the inner function, and then cubing it is the sort of the outer function. Okay, so in this case, f of x is x cubed, and sine of x is the g of x, the outer function and the inner function. Okay, now let's find the derivative using the chain rule. Okay, so now we need to find f prime of x. Which of course is just 3x squared. And then we need to evaluate the derivative, f prime, at g of x. Where g of x is equal to sine of x. Okay, now remember, the derivative, what does the derivative do to any number that you plug into it? It squares it and then multiplies it by 3. So if you're going to plug sine of x into the derivative, it's going to square that. So it's going to give you sine squared, and then it's going to multiply that by 3. Okay, so this is our outer derivative, and now we just need the inner derivative, which is g prime. And of course, the derivative of sine is cosine. Okay, so dy dx is going to be the outer derivative times the inner derivative. So this is your outer derivative times your inner derivative. And notice that you do get a different answer from the previous one, because sine cubed of x is not the same as sine of x cubed, like we did in the last problem. This should be squared, sorry. So, I just left the square off, so it's 3 sine squared times cosine of x. Okay, now I do want to show you that you can also do this using the first form of the chain rule. And you will get the same answer. So if you wanted to use the first form of the chain rule, then instead of breaking this up into f of x and g of x, because if you're going to use the second form of the chain rule, you do have to write it as f composed with g. So you have to determine what f and g are. Okay, but if you're going to use the second form of the chain rule, you don't need to do that. But what you do need to do is you need to write y in terms of u, and then you need to write, and in this case, u needs to be written in terms of x, and y needs to be written in terms of u. Okay, so in this case, u is always the inner function. Okay, and so in this case, the inner function is sine of x, right? Just like it was up here. Okay, so this is going to be sine of x. And then this is going to be your outer function. But it needs to be written in terms of u. And so it's going to be u cubed. Okay, remember, if you're going to use this form of the chain rule, y needs to be written in terms of u, and then u needs to be written in terms of x. This is going to be your outer function, and this is going to be your inner function. So when I look at this, I go, okay, what's the inner function here? Right? Well, if you write it like this, it makes it clearer. The inner function is sine of x. So I'm going to let u be sine of x. Okay? And then your outer function is cubing it, but you need to write it as u cubed if you're going to do it this way, because y needs to be written in terms of u. Now notice, if I take u and substitute sine of x for it, since u is equal to sine of x, I do get sine of x cubed. Okay, so this kind of forms a composition that gives you y equal to sine of x cubed. Okay, now let's find the derivative. of y with respect to x using the second form of the chain rule. So dy dx is the same as dy du times du dx. Now remember, this is the outer derivative and this is the inner derivative, so we should get the same answer. Okay, so let's see, what's dy du? Okay, well, the derivative of y with respect to u would be 3u squared. Okay, and then the derivative of u with respect to x. Well, that would be the derivative of sine of x, which happens to be cosine of x. Okay, now remember, this is your outer derivative, and this is your inner derivative. That's coming from here. This is your outer derivative, and this one's your inner derivative. Okay, and then the last thing you need to do here is go back and substitute for u. U is equal to sine of x. So this is really 3 times sine of x squared times cosine of x. And again, we typically write this as 3 sine squared of x, like that. Okay, but notice you get the same answer as you did when you use the other form of the chain rule. Okay, so whichever form you prefer is fine. It would be good that if you were comfortable with both forms, okay? But a lot of people start to get more comfortable with one form or the other, and they begin to use that one more and more. And so whichever form you're more comfortable with, you're more than welcome to use. But you should be familiar with both of them. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.